Hi guys, so this next video is trying to build up to some long division skills. And again, I want to make sure we cover some of the basics before escalating. My end goal is to show you two ways that everybody can do these two problems. I don't want to just do them without you understanding why or how. One of the biggest pitfalls with long division is people will see something and they'll just remember multiply, subtract, bring down, and they'll just keep trying these things, but not really understanding what's going on. So I'm working with sixes to begin with. That's what this multiplication chart is I made over here. And one big phrase today is without going over, okay? And we'll see that come into play in a second. So first, what is division? 42 divided by 6. I love to just say what I see. It helps to clarify things. Anytime you read something out loud, it helps. So 42 divided by 6. This could mean, one of my favorite ways to think about it is money. I have $42 and 6 people. How many dollars are each person gonna, how many dollars is each person gonna get if I split 42 among 6 people? Like, this is splitting usually. The other way to think about it is I have $42 and I'm gonna pass out 6 at a time. How many people could I give that to if I did it that way? So there's two ways to think about division. So one thing we see is, in some quick academic terms, the dividend is the front end when it's written like this. That's how I remember. You have a divisor, and then your answer is a quotient. One of my favorite things to do is just to remember that these are always fact families. What's the opposite of division? It's multiplication. So my answer, whatever it is, I'll rearrange this and say 6 times my answer should give me 42. So I don't know that yet. 6 times something should give me 42. So maybe you can look over here in the chart already and say, man, I already know this. Why are we doing this? 42, I'll just come to 42. Must be 7. Or 6 times 7 is 42, easy. Okay? It starts off easy, but I want to make sure that you see, where we're going in an easy one, and then we'll escalate on these two. So what throws a lot of people off is when you rewrite it using sort of, I don't know, I should have looked up the official term for it, but sort of the house or the bank vault, whatever you want to call it. And yeah, somebody's going to beat me up at school until I figure that out. The first number, the dividend, is what goes inside. So I always call it the bank vault because I usually talk about it in terms of dollars, like $42 split among 6 people, 6 robbers. So I have $42 in the vault, and then it's going to split among 6 people. How much money are they each going to get? So one thing I like to do too, division is like the only time that you're going to look at the biggest digit first. And what I mean by that is I'm gonna ask many times, like, how many times does 6 fit into 4? How many times does the outside number fit into the number we're looking at? Okay, and really the better way to phrase it would be like, how many times can I divide 4 by 6? I don't know why my vocabulary or approach is to say how many times can 6 fit into it, but it really is the same thing. I guess it's more like this version. So without further ado, let's look and say, all right, if I'm going to start with my biggest digit, what I should do is this, and I'll say, all right, how many times can my 6 fit into 4? And really, rewind, we did this in class, where we said 42 is 1, 2, 3, 4, and then 2 ones, right? Each of those is a 10, and these are 2 ones. And if I'm going to split it into 6 groups, right, 1, 2, 3, 4, 5, 6, and I'm going to try to evenly split those up. So if I'm starting at my 40, you can see right away, like, I'm not going to be able to put a 10 in each group, because if I did that, I'd have to have 60. But I got to be able to split stuff up without going over. So in real life, what we did is we took these 10s and we broke them up, and we made 40 more 1s. So we would say, all right, turn those 40 10s into 40 1s, right? And I won't write them all out here, but it's like 41. So we have a total of 42 ones. Now we can split them into different groups. That step right there is the same as this one, where I say, hey, this 40, how many times can I split this 40 into 6 groups as 10s? I can't. And so one thing I do right now is I'm going to put a 0 over it and say, no, can't do it. No. And what we need to do is always say, all right, 6 times that number. And this comes to this acronym, multiply, subtract, bring down. I say 6 times that number, what is it? 0. So I'm going to write my 0 down here. That was the multiplying part of multiply, subtract, bring down. Okay, so now the next step would be subtract. So I have two numbers stacked, 4 and 0. I'm going to go like that, subtract it. And what really do I have? I have 4. And what's my next letter? It's B, bring down. So now I'm going to do that. So really what I did is I said 4 tens? No. But how about 42 ones? Because I'm thinking about it in terms of my last digit. So how many times can 6 fit into 42 or 42 to be divided by 6? I'm going to use the chart and say, all right, I'm going to come down and I'm going to get as close to 42 without going over. So 42 means 7 can go in each group. If I said 48 and said, oh, 8 can go in each group, well, if over here I try to put 8 in each group, 1, 2, 3, 4, 5, 6, 7, 8, 8, that's 32. Another 8 is 40. And it's like, oh, sure, that's great. Wait, how'd you get 48, man? So kind of rewind and say, no, it can't be 8. All right, so 6 times 7 gives me 42. All right, so multiply those two, because 6 times 7 is, and I'll say the number, 42 again. Now I'm going to subtract it, and I have nothing left over. When you get to sort of the end here, there's invisible decimal places, but we would say, listen, we're done. We have no remainder. Our answer here to 42 divided by 6 is 7. Okay. Moving on to the 55 divided by 6, we're going to add a wrinkle. So I want to rewrite it first. I never want to do division problems in this way. I'm going to get crushed. So what I do is put my first number inside, because that's what's being split up, into 6 groups. All right. So my first thing is, again, to look and say 6. How many times can 6 fit into 5? And remember, it's 5 tens. At a point, I guess it's unfortunate. Like when I plow through the standard algorithm, I just see the 5, and you get so used to it at a point. I think a lot of kids in our class are there. But if you're just learning, I think it really helps to say, you know what, this is 5 tens. I can't put that in even groups. I'm going to have to break it up. So I say, how many times can I split this 5 into 6? I can't. So I put a 0. 6 times 0 is 0. Now I'll subtract. 5 minus 0 is 5. And then my next step is to bring down. Another thing that throws people off is they'll get here, and then they'll try to compare this 6 to something like this 5 over here, and they'll get a 0 again, and they're not sure what's going on. You're always looking at now, once you get started, compare your outside number, your divisor, to the bottom number. You're looking down. I want you to look down with your arrows. So how many times can 6 fit into 55? Come over to my multiplication chart. I'm going to get as close as I can to 55 without getting over. So these are really the two options. If I chose 60, I'd be going over. I cannot do that no matter what. So 54, and sometimes it helps right here to just say, hey, listen, it's a 9 and a 54. Those two numbers need to go on here immediately. 9 on top, 54 on bottom. So I just multiplied 6 times 9 to get that 54. And this is another mistake people get. They're like, oh, they found 54, they put a 9, and they'll write 55. They're not sure what to write down. You're always writing down the factor, which is the outside, and the multiple. Don't write down this number again unless that happened to be your multiple, okay? So 55 minus 54, I have 1 left over. And so in our old terms, we'd call that 9 remainder 1. We will talk more very, very, very soon about other ways to write that as a decimal or as a fraction. Okay, for our sake, we'll just call it a remainder today. That's what you need to know. So my last one, 193 divided by 6, I rewrite it. 193 divided by 6. Okay, so now I've got 100, 9 tens, and then 3 ones. I look at the 100. Can I take a 100 block and now put that into multiple groups of 6? No. So this is where I say, hey, how many times can I split that 100 into 6 groups? 0, okay. And I'll say 6 times 0 is 0. All right, and you'll see a shortcut. Some people will just say, I can't do it, and they'll scroll right over. The only reason I like to do this is because I'm putting a 0 above the place. It doesn't take me more than 2 seconds. But then when I'm writing my other numbers, I know exactly where I am. When I get here, I know I'm finished with my answer, basically. And whatever's left over is a remainder. So it's just my strategy. So 1 minus 0, 1. Okay, it's like I'm turning that 100 now into a bunch of 10s, so now I have 19 tens. 6 can fit into 19 without going over. Let's look. 6, 12, 18. It's this column here. So I'm going to say 3 times 6. It can go in 3 times. Because 6 times 3 is, and don't write 19. What was 6 times 3? It was 18. And now I'll subtract it. Got a 1 left over. Multiply, subtract, bring down. So my last digit is here, my ones place. So I have 13 ones left over. And really, think about it. I had a 10 left over here. I'm going to break that into 10 ones. So now I have 13 ones, just so I can more easily split it up. Really, it's like being a banker in Monopoly, and you're passing out, smaller increments. You got to break money up sometimes in order to do that. So that's kind of what we're doing here. 6 can fit into 13 without going over twice, because 6 times 2 was not 13, 12. Now I subtract it. I have 1 left over, and my answer then is 32, remainder 1. If I were to work backwards to check my answer, what's interesting about this is I'll do it. 32 times 6 plus that 1 should give me 193. So I'll do it up here, 32 times 6, and I'll wait and add 1. I want to remember that. 6 times 2 is 12, so 2 and 1. 18, 19, 192. Add 1 more, and sure enough, it's 193. Okay, so the big ones. Come down to the big ones, and I'll show you the 2 methods. The first one is, make a times table. This is for folks who want to be sure and methodical, no mistakes. So you just make your own times table. So you say 23 on top, bring this down, and we say 1, 2, 3, 4, 5, 6, 7, 8, 9. What's interesting is you don't need the 10, but it'll help you find some of the other values. And then you'll fill this in however you need to. So I know the first one, 23 times 1 is 23. This happens to be a friendly number, so I can say 46, 69. Don't go too fast, geez, I'm about to make a mistake. And then I'll fill out some of the harder ones. So I know times 10 will just be the same number with a 0, 230. Half of 230, I can do it. I know it's 1 and then 15. And then another neat trick is you can start using these to find future values. Like if I want to find 6, I could do 69 added up twice, or I could do this 5 plus the 1. I'm going to come back and add some 23s because this looks easy. So 23 more is 138. 23 more. Oh, I got to come off to the side. I just don't have it right now. Is that okay? Yeah. I'd rather be slow and right than fast and wrong. Easy now again, so I can 23 more is a 4 and an 8. 23 more is going to be a 7 and then a 2, 0. And I love to just check to make sure. 23 more, sure, 230. So my last one here, 69. I'm actually going to do this 46. I'm going to double it. So it's a 2 here, be 92. Yeah. Double check, look, make sure, yeah, 612, okay. All right, so now I come here. Now that I have this problem is really easy. I'm going to rearrange it and say I've got 627 inside my vault, split among 23 robbers. Oh. So I look and I say, all right, how many times can 23 fit into that 6 without going over? 0. 23 times 0 is 0. I'll subtract it, and what do I still have? I've got 6. I'm going to do a bring down. 2. So 23 can go into 62. Oh man, this is so hard. Oh, but look, let's use this. Without going over, looks like 46, 2 and 46. So I'll just write those 2 down right now. 2 and 46. What do I do here again? Subtract. Oh, now I gotta do some long subtraction, 2, I cannot do it, so I'm gonna borrow 5 and turn that into a 12. 12 minus 6 is 6, 5 minus 4 is 1. And my last step here, I shouldn't say last step, but last bring down, 167. So I'm glad I did this. I can come over here and say, all right, close to it without getting over. And write these perfectly sideways. I see you guys writing them like diagonal and chicken scratch, and then you end up choosing the wrong factor. Go clean with this stuff. So 161, 7 and 161. So I'll put my 7 here and then a 161. Subtract it out. That's actually going to be really easy. 7 minus 1, 6. And then the others don't have anything. So my final answer, I got to put that as a remainder and say I got 6 left over. Remainder 6. Okay. I can come back through and check to make sure I'm right. All right. But we're going to proceed to the next one. Just so my video isn't too long. Next one. This is called more of the guess and check. It's when you're feeling really comfortable with your numeracy. All right. You need to decide what can you handle. If you're good with long multiplication or the standard algorithm, go for it this way. Just whatever you do, be right. So I got to rearrange it. Okay, I'm going to split 5,846 among 37 robbers. I think they're going to get more money each. Look at that, $27. It was a good job earlier. 37 on the outside. So what I'll do is, first of all, just do the easy steps that I can. And I'll say, all right, 37 into 5? No. 37 times 0 is 0. Subtract, and I have a 5. 58, bring that down. And I just randomly wrote these numbers in. So if it's really easy, I hope it's not. I don't think it will be, because I think the next one's going to be kind of nasty. So anyways, whoa, slow down. I want to bring that down to here. 58. I can tell it's only going to go in once. And 37 times 1 is 37. Subtract it. So now I'm going to have 1 left over. 5 minus 3 is 2. 21. Now we got to go. Good, I'm glad. 214. I don't know 37s. No one does. So what I'll do is I'm going to start kind of guessing some things. I know 37 times 10 is 370. So I'm just going to come off to the side and guess something and say, you know what? Let's try 37 times 5. Let's just see. Okay. 5 times 7 is 35. 15 and 3 more is that 185. Jeez, was that a good guess? Should I just, I'm not sure, right? I'm like, is that enough? Could I add more, 37 more? So if you know your multiplication standard algorithm, this goes really fast. I'm going to see about 6 really quick. 37 times 6. That's going to be a 2 here, carry a 4. 6 and 3 is 18. 4 more, though, is 22. All right. So I'm guessing and checking, right? If this was too big, I would have guessed a number smaller, like 37 times 2 or 37 times 3. If it was way too small, like say I needed to get to 350, then it would have jumped up maybe by 2 or 4 or something like that to say 37 times 7, 37 times 9. But this is guessing and checking, and I do it until I find what works. So think about it for a second. I got 185. That's what I need down below. And what goes with it up top? Well, that's your factor. So I'll put a 5 on top and then 185 below. Okay, subtract it. And I'm going to have 4 minus 5. Ugh, can't do it. I'm going to come next door and borrow. Turn you to a 0, 14. 14 minus 5 is 9. Same problem. 0 minus 8, I can't do it. So I'm going to come over here, break up this 100. Now I have 10 tens minus 8 tens. I have 2. And then 1 minus 1 will cancel out, so I'm left with 29. Nice. We're going to have a nice big nasty one at the end. So now I bring this down, and I've got a 6, 296. So look here. We can use our previous guesses to help us out. I had 222. I'm going to be brave. I think I can get 8 in. So I'm going to try it. 37 times 8. Spoiler alert, I think I'm wrong, but I'm just going to do it. 8 times 7 is 56, so 6 and a 5. 8 times 3 is 24. 5 more is 29. 296. Oh, are you serious? Wow, seriously. Earlier I just randomly made those up, but you don't care. All right, 296. I mean, man, I think I'm going to double check this because I'm freaking out here. So 8 and 296, so I'll put an 8 here. Now 296 down here. Is this for real? And then I'll subtract it, and I'm saying 0 is left over. I have to know, and I got to see, if I made a mistake. So I'm going to do 158 times 36. Remember the fact family. If you reverse it, and that you ought to get the same answer. I'm looking for 5846. 6 times 8, 48. So put an 8 here and a 4 here. 6 times 5 is 30, plus 4 more is 34. 4 and 3. 6 times 1 is 6, 3 more is 9. 9. I'm going to cross those out so I can come here and just focus on my 3. Now remember, it's 30, so I got to put a 0 first. It's to my tens place. 3 times 8, 24. 4 and 2. 3 times 5 is 15. 17. So 7 and 1. Come on, man, you got to work out. 3 times 1 is 3, plus 1 more is 4. All right, guys, let's see. 8. Oh, no. You know what? I don't even know. So I'm getting 8, 8, 6. What did I do wrong? What the heck did I do wrong? 22, 37 doubled. So now you guys get to see me mess around and look amateur here. It should be 4 and 74. 74 more than that is 296. Dude, what am I doing here? What is going on? 5846. What did I do wrong? I feel like I gotta scrap this video. I don't know. Should I go back through and now I need to like redo it, the whole thing. I feel like a dope. 74 more. I mean, that worked out. 688. Let's just see what I ended up with. 5688. What the heck? Oh my word. This. See, this is what happens. If I just took it and ran with it. Do you see? Do you see with me? I'm kind of glad I'm doing this. It wasn't 36, man. What am I doing? It's 37. So this is kind of good. Okay. I was freaking out. Let's try it again. Oh, this is all genuine, by the way, folks. But this is the sort of stuff we got to do to make sure we get the right answer. Everybody does dumb stuff like this. You know what I could do? I'm just going to try this really quick. 6 and carry 1, I have 5. 5688. If I add another 158 to this, because remember up here was 36 158s, and I needed 37. So really it's like another 158. And if you've lost me, I mean, I'd say, like, try to think about what I'm doing here. But now 8 plus 8 is 6, carry a 1. 13 and 1 more is 14, so 4 and carry that. 6, 1 and 1 is 8. Oh, yeah, man. 5846. Okay. Anyway, guys, that's math sometimes, you know. So were I to do this, I would get the same thing. I'm really happy. So all the math is correct, except, hey, that was my error. I wrote down the wrong factor there and divide by that. So 1 extra 158. Sure enough, 37 158 gives me 5,846. So hope you enjoyed my messing up, sort of. You know, I got the right answer. And I stuck with it, and you're going to have that same experience. So, anyways, if you have questions about this, I would really say, watch the video again, see if you get what's going on, but then come see me, set up a study session, and we'll get you there, promise. So, thanks, guys.